In this video, we're going to be determining the density of a rock. So let's say that you have these two scenarios. You have this cup, and it's going to be filled with water. You have this ball, and it's going to be hanging above the cup. And then in the second scenario, you have the ball, but it's dunked into the cup. So here you would record the tension in the string as the rock is suspended in the air. We're going to use the mass of the rock, and then we're going to lower it into the fluid. So in this problem, our fluid density is equal to 1193 kilograms per meters cubed. Our gravitational field strength is equal to 11.03 newtons per kilogram. So you can say that our tension in the air is going to equal to 17.87. Our tension in the fluid is equal to 1012. And now we can find the buoyant force. So buoyant force, when the rock is lowered into the fluid, it's going to decrease your tension because the fluid is going to push up on the rock. So your buoyant force is equal to your tension in the air minus the tension in the fluid. So we can just substitute in our values. Here that is 17.87 minus 10.12, and that's equal to 7.75. Now we can also find the volume of the rock. Archimedes' principle says that FB is equal to rho F times volume G. So if you solve for volume, you have FB over rho F times G. All you do now is you just substitute in your FB, which was 7.75. You divide that by your density of the fluid, which is 1193, multiply that by 11.03. And if you plug this into your calculator, you're going to get your volume of 589. Now let's also find what the density of the rock is. So first we can find what the rock's mass is to get our density, because density is equal to mass over volume. So our rock mass, you're going to use the fact that since the tension is hanging at rest in the air, we can say that the tension in the air is equal to the weight. So if you rearrange this and you solve for your mass, you can plug in what our tension in the air is. So we know that the tension in the air is 17.87. And gravity here, our gravitational field strength is 11.03, not 9.8. So if you plug this into a calculator, you're going to get approximately 1.620. We know that for density, we actually are going to use this symbol, not that one. We can just plug in our mass, 1.620 divided by 5.8 . And this is going to give you approximately 27050.65. We're going to round this to 2,751. So now we have our buoyant force, FB in newtons. We have our volume, 589 in milliliters. And we have our density in kilograms per meters cubed.